A very good morning, students. Welcome back to my channel, which is Teacher Cool, and today we'll be continuing with the thermodynamics class. And in this class we'll be doing the second law of thermodynamics, the entropy and its application, and all other topics which are related to entropy. And this is an important class because many students face confusions between entropy and second law. What is the difference? How do we state the second law of thermodynamics? So we'll be going at a very slow pace. So let's start. Major topic which we'll be covering is the entropy plus the second law, right? Okay, so let's start. The first thing when we talk about entropy is entropy को हम define कैसे करेंगे, ठीक है? तो सबसे पहली चीज entropy को अगर मैं define करूं, entropy को अगर मैं define करूं, right? तो एंट्रोपी को देयर इज नो फिजिकल डेफिनेशन फॉर एंट्रोपी, लेकिन जो एंट्रोपी होता है इट इज बेसिकली अ कंसेप्ट. मतलब हो क्या रहा है, इट इज नॉट अ प्रोसेस, इट इज अ कंसेप्ट, राइट? तो मैं बोलूंगी कि मेरी जो एंट्रोपी है वो क्या है. एंट्रोपी इज किसी भी एक सिस्टम के अंदर द डिग्री ऑफ disorder. Any system which has some kind of disorder in it is its entropy, right? Like, or you can say it is the degree of randomness or anything like this. Like, we say that whenever we are talking about crystals, they are perfectly in order with its molecules. You know that every molecule is at its specified position. वो इधर उधर नहीं होते हैं, disorder में नहीं होते हैं. Just like when a teacher is present in the class and the teacher is very strict, तो students क्या होते हैं, वो अपने respective benches के ऊपर टिक के बैठते हैं. Like, right? So similarly, when the teacher is present, we call it a crystal or a system which is in order. Now suppose the teacher walks out of the class and all the students know that the teacher is not coming back for a while now. So what will happen? Every student will get up from his seat, go to his friend's seat, they'll talk, they'll play, they'll create a mess, right? So that is the change in entropy of the class. It was in order and now it is in complete disorder. So this transition is the change in entropy, right? Okay, so the physical कह लो या layman language में कह लो तो हम क्या बोलेंगे, entropy is degree of disorder or degree of randomness in a system, right? तो एंट्रोपी में you can very well see that every single process which is occurring on its own in this universe is basically proceeding towards randomness. अपने आप कोई भी ऑर्डर में नहीं होता है, उसको ऑर्डर में डालने के लिए we need some energy or we need some input force. But the spontaneous processes, every single spontaneous processes is proceeding towards the disorder. अगर हम लिखें तो हम बोलते हैं कि every process is basically of two nature. This is the spontaneous, which is occurring at its own, and the second is stimulated. Now stimulated is the one in which we provide some input. So stimulated one can proceed in order also and in disorder also. So this is not a case for right now. So as of now we are talking about the spontaneous processes which is occurring at its own, right? Like in warm countries, the water will the ice will melt, right? That is the spontaneous process. So it is going towards a disorder. In case of cold countries, the water is freezing. That case is an exception, but in that case also what is happening, the water when it is freezing, its molecules are freezing in disorder nature, not in a perfect nature. That is why we get this kind of structures of ice, because it is expanding and it is freezing in disorder only, right? So this is our spontaneous and stimulated processes. Every single process which is spontaneous is basically in turn increasing entropy. Now, किसकी एंट्रोपी को वो इंक्रीज कर रहे हैं? हम कोई सिस्टम नहीं ले रहे हैं, हम एक यूनिवर्स की बात कर रहे हैं, तो हम बोलेंगे एवरी प्रोसेस विच इज अकरिंग इन universe and it is spontaneous in nature, it will increase the entropy of the universe. Am I right? Okay. Now, what is the increase in entropy of the universe now? First thing, before we talk about the increase in entropy, there is a concept of absolute any property or any quantity. When we study, we always talk about the absolute quantity. So let us understand first what is absolute entropy. Okay. तो एब्सोल्यूट एंट्रोपी क्या होती है कि जब हमारी एंट्रोपी किसी भी सिस्टम विच इज अंडर ऑब्जर्वेशन इज जीरो, वी आर टॉकिंग हाइपोथेटिकली राइट नाउ एंड वील रिलेट इट टू द रियल थिंग. सो वी से एब्सोल्यूट एंट्रोपी मीन्स द इनिशियल एंट्रोपी first thing, entropy को will denote with the S. So absolute entropy means the initial entropy SI should be 0 for the system which is under observation, and we'll say what is the absolute entropy. अगर मेरे पास initially 0 है तो at any instant, say time ST is suppose 10. I'm just writing the magnitude right now. So when I'm comparing this ST's entropy at some particular time with respect to initial which was 0, so this magnitude of 10 will tell me the absolute entropy of that system at that instant of time. But the problem is, when is the entropy 0? In the previous lectures, we talked about the absolute zero of temperature. What was that? The absolute zero of temperature was absolute zero of temperature was temperature at 0 Kelvin. We said that it is the lowest temperature which we can achieve, and in that case also we said that we cannot actually in real world achieve this temperature. Why? Because at this temperature every single motion or every single vibration, it just ceases. So there is no motion and there is no kind of movement or anything which can take it further. So even before reaching the 0 Kelvin, से 10 Kelvin तक ही हमारी हर चीज क्या हो जाती है, स्टैंड स्टिल हो जाती है, और उसके बाद we cannot do anything. So this was my absolute zero of temperature. But for the time being, let us say even at this point I have achieved this temperature, and with respect to this temperature, whenever we are talking about energies, we say the lowest energy of the purest molecule. we say energy of the purest molecule at 0 Kelvin. ये जो एनर्जी होगी इसको हम क्या बोलेंगे? 0 पॉइंट एनर्जी. वाई 0 पॉइंट एनर्जी? क्योंकि ये 0 केल्विन के ऊपर है, तो हम इसको क्या बोलेंगे? 0 पॉइंट एनर्जी. अब 0 पॉइंट एनर्जी की अगर मैं डेफिनेशन बोलूं तो 0 पॉइंट एनर्जी इज द मिनिमम एनर्जी विच अ मॉलिक्यूल हैज एट इट्स लोवेस्ट ऑफ टेम्परेचर, विच इज 0 Kelvin. And hypothetically or assumption wise or the predicted wise, this energy should be 0 joules or 0 calories because it is at 0 Kelvin. But when we get the experimental results, we come to a conclusion that even the 0 point energy is not equal to 0. It has some minimum value. It has say 10 joules or say 0.010 joules, but it is not 0. It has some minimum energy, which is the lowest energy a molecule can have even at the 0 Kelvin. And we come back to the conclusion, SI is equals to 0. That means the entropy of any molecule can never be equal to 0. Is it clear? Why it is not equal to 0? Because the 0 point energy itself is not 0, so this cannot be 0. Anything can never be in perfect order in this universe, even at the absolute 0 of temperature. So this says that the initial entropy can never be 0. Therefore, this ST will basically denote the change in entropy, that is delta ST, which will be equal to ST minus S0 or SI0, which as a result states that there is no concept of absolute entropy, but it is the change in entropy. We will never say that entropy of that molecule is this. We will always talk like this, that the change in entropy of that system in that interval of time is this. There is no concept of absolute. I hope it is clear to you why it is not possible to have the absolute entropy. So this was the reason, right? So let's come back to the universe part. यूनिवर्स में क्या बोला हमने कि स्पॉन्टेनियस प्रोसेस जो होगा इट विल इंक्रीज द एंट्रोपी ऑफ यूनिवर्स. That means whenever it is talking about the increase in entropy of the universe, it means that the change in entropy of the universe at any instant of time which is equal to delta S is always positive, or it is always greater than 0, right?